Today I would like to present a paper which is titled Resource Misallocation and Manufacturing Productivity, the Case of Ukraine. The structure of my presentation is introduction, literature, methodology, data, then I calibrate parameters, empirical results, and finally I'm going to conclusions. So, while looking at relation between business condition in a country and its GDP, it's possible to notice this graph as at the x-axis that's doing business conditions, so the right are better, to the left are worse, and on the y-axis that's GDP per capita. So one can notice that the better doing business conditions in a country, the richer a country. However, as due to the shape of the scatter plot, I concluded that minor changes are not working. So only significant improvement of doing business conditions can boost growth of countries. So these conclusions, so from simple graph, motivated me to understand how by improving doing business we can improve our output. So and how the mechanism works to, within the methodology I'm applying. Market environment affects productivity in a country, and productivity affects output. And this idea came from different areas. So at first, at macro level, in seminal papers in growth theory, it was proved that TFP is one of the main sources of economic growth in a country. Then it was proved that actually it is the most source of growth. Sometime later, when micro foundation of macroeconomics started to emerge this flow, it was proved that idiosyncratic distortions which affect each country, each firm, they affect their productivity, so it's better to study overall productivity from micro level perspective. And finally, the methodology which I am applying, it assumes that market conditions they affect firm level productivity because of some distortions. Firms are unable to employ optimal amount of resources, so they are less productive. As a result, productivity in the industry is also lower, and this lowering overall output, and thus the country becomes poor. So thus my motivation is using this methodology to provide rationale for reforming doing business environment. And research question which I am posing in this paper is, what are the potential gains of optimal resources allocation in Ukrainian economy? And studying, learning literature on this question, I decided to impose initial hypothesis that better allocation of resources can improve productivity in Ukrainian manufacturing by from 30 to 80%. And this literature emerged from a paper by Sai and Klinov, which in 2009 published their paper where they studied effects of micro-level resource misallocation on manufacturing productivity in India and China. And after that, a number of studies was published, and this paper is a part of this flow of literature. And the contribution of this paper is to perform this exercise for Ukrainian economy. So, speaking about methodology, general setup is that I apply Xi and Klinov model, which is based on closed economy variation of Melis model, That's a monopolistic competition model with heterogeneous firms, and firms differ in productivity and distortions they face. And also it should be mentioned that coefficients in production functions, they vary between industries, but not between every specific firm. So at the firm level, goods are produced with Cobb-Douglas production functions. Then, while we aggregate them into industry level output, CIS production functions is applied, and finally single final good which is produced by representative firms. It combines output of manufacturing industries using again Cobb-Douglas production function. And as I already mentioned, that firms here differ by distortions that face. A paper by DS Marcus and Richmond lists very good examples of such distortions which are covered by this methodology. So, for example, what can distort firms' production? For example, non-competitive banking system provide favorable loans to some producers based on non-economic criteria. On the other hand, financial institutions can be unable or unwilling to provide credit to firms that are highly productive, but they have no credit history, or they can prove that they can pay back, but they are really good. On the other hand, government may offer subsidies, may offer special tax deals, or lucrative contracts to specific producers. On the other hand, various product and labor market regulations also can change costs of labor and cost of capital. Enforcement of tax collection also can distort firms' production. And finally, of course, is corruption. As corruption in Ukraine is a very important factor which distorts production of Ukrainian firms. So, in order to calculate these gains of optimal resource allocation, I follow three main steps. So, at first, I compute firm level TFP, then I move to industry level TFP, and finally, I aggregate it in aggregate manufacturing productivity. So, at firm level, as it was mentioned at previous presentation, who heard it. So we compute output wage and capital wage. Output wage is defined as a relationship between share of labor which should be applied according to production functions coefficients, and we compare them to actual share of labor. And output wage shifts both capital and labor productivity in one direction. On the other hand, capital wage is computed as relation between relation between labor and capital as it is predicted by production functions and the actual relation. Based on these distortions, we compute marginal revenues. As I was told that these distortions, they affect productivity of factors of capital. So, for example, in marginal revenue of labor, we use output wage, which distorts optimal wage, and for marginal revenue product of capital, we adjust optimal rental rate by these distortions. Then we aggregate this into total physical productivity, which is actual productivity of firm, and total factor revenue productivity, which is believed to decrease when firms are productive, and and increase when firms are less productive, as more productive firms can impose lower prices, so their revenue productivity will be lower, and less productive firms have no room for maneuver to decrease prices in order to be profitable. So this total factor revenue productivity is the main measure of distortions at firm level. Then we move to industry level. At the industry level, we aggregate productivity of every single firm to average industry level productivity, and we aggregate it as harmonic average of physical revenue, which is physical productivity, which is actual productivity of firms, and we weight it by deviation of revenue productivity of firm from the average revenue productivity in the industry. As I was told that in ideal case they should be equal to the mean. Then in ideal effective situation, effective industry total factor productivity will be just the mean physical productivity. And at aggregate level, we again just aggregate these industry level productivities to the aggregate productivity and aggregate output. And gains of liberalization of market conditions, which means that we rule out all the distortions, are computed as relation between actual total factor productivity, overall productivity, and the effective one. And then again we just recalculate it in percentage terms. And here I would like to mention that this is a formula for an ideal case, and so all the distortions are ruled out. However, this situation does not seem to be real, as in any case some distortions will affect industry in the country. So we also apply a benchmark distribution of distortions, and I would like to apply the same benchmark which C.N. Klenov applies. So that's the U.S. economy. So I take their measure of TFP gains and adjust Ukrainian TFP gains by these gains, and obtain potential TFP gains if we move to US distribution of distortions. Speaking about data, just briefly speaking, I use balances and financial statements of all manufacturing companies in Ukraine. The period is from 2000 to 2010. I use revenue, wage bill, employment, book value, fixed capital, stock, material cost, industry code, ownership, exporting and importing indicators. I construct value added, fixed capital measure, exit enter variable, and age variable. I adjust data for deflators, for revenue, fixed capital, material cost. I adjust by production, by producer price index. Wage bill is adjusted by CPI. Some steps for data cleaning are made in order to satisfy that all firms have positive revenues and positive inputs. I trim those cases where production function estimation wasn't satisfied the properties of Cobb-Douglas production function, also as it is done in the seminal paper, which I replicate. The outliers here are tails of TFP and wages distribution. So the most productive, the least productive firms are dropped, and also those firms which are subject to the highest distortions. As a result, I came to final data set of almost 200 18 observations for approximately 53,000 of unique firms, and the price of data set more or less robust to outliers that from year to year I lost from 23 to 32% of value added. Some descriptive statistics are presented here. So descriptive statistics for the whole sample, inflation adjusted data over the last period. So we could see that turnover value added wage bill material cost increased to 2009, which was the year of financial crisis in Ukraine. So it was a drop, and then some recovery occurred in 2010, as it's the last year in the last period. However, further adjustment, further improvement then occurred. Also, size structure. Here we could see that in our sample, 1% of the biggest firms produce almost 40% of value added and employ almost 36% of labor, which is in line in general statistics for size distribution of firms in Ukraine and their economic weight. Also, analyzing for dynamics, we can see that till the crisis year of 2008 and 2009, it was observed net enter of firms, and during this crisis year, net exit started to emerge. I calibrated parameters for this model in order to make it more precise for Ukrainian case. Syn Klenov, they assume that the rental price of capital is 10%, 5% for real interest rate, 5% for depreciation. But I analyzed real interest rate over the last period, decided to take median of this real interest rate, and also I took more precise number for depreciation, so I came to 11% rental price of capital. Speaking about elasticity of substitution between plans variable value added, I decided to stick to the value which Syn Klenov used. Speaking about elasticity of output with respect to capital, which is production function, our production function parameters in the original paper, they share of capital was calculated as unity minus wage bill share in the corresponding US industry, and I decided to calculate these shares on my own, and I decided to use fixed effects method to estimate value added specification of production function. Now let's move to empirical results. So the first graph is distribution of physical productivity, which is believed to be the actual TFP of manufacturing enterprises. We can see that 0 here is the mean productivity. So most enterprises underperform this mean productivity. However, only minor enterprises outperform this productivity, and it could be explained that those biggest enterprises, which there are few of them, but they are the biggest and the most productive, so they shift this average productivity, this mean to the right, and all the remaining firms remains to the left-hand side. And over the last period, before crisis, mean productivity shifted to the right, so it's gradually improved, and also distribution also improved, so it became more normal. But after crisis, the situation worsened. Now let's move to revenue productivity variation, which in this methodology is the measure of distortion. So we could see that while analyzing through the period which is under analysis, so from 2002 to 2007, resource allocation slightly improved by after financial crisis, as variation of total factor revenue productivity began to increase. This is a signal that allocation of resources began to worsen. And also analysis on some dummy variables show that small private enterprises are the least productive and the most distorted. The most distorted industries are radio, television and communication equipment industry, coke, refined petroleum products, office accounting and computing machinery, and the least distorted industries are food products and beverages, rubber and plastics products, and other non-metallic mineral products. Having this data, this analysis in our having this analysis, we can obtain gains of resource misallocation elimination. So if we eliminate all the wages, so in an ideal case, if we eliminate completely all the distortions, we can improve manufacturing productivity by almost from 97 to 135%. However, if we apply benchmark distribution of distortions, which is US, as by Klein it was computed that for US these gains approximately 47%. So the gains shrunk to from 34 to 60%, which satisfies our initial hypothesis. A hypothesis was made for these benchmark distribution gains. During the last period, allocative efficiency improved slightly, but if we separate this period in two periods, so to pre-crisis period, allocative efficiency improved by almost 19%, and then it worsened by almost 12%. Aggregate manufacturing productivity increased by 70% or 6.2% annually, and taking average annual increase of allocative efficiency improvement, we can conclude that better allocation of resources is responsible for almost 9% of aggregate manufacturing TFP growth. Then, moving further, if we assume that we eliminate all the wages, we can decide that all the firms produce their optimal amount of production. So we can compute how firms currently produce less than they could produce in an ideal case. So we compare actual distribution of output and effective distribution of output. So the actual distribution is this one which is more narrow. However, effective distribution is are these two distributions which are shifted to the right. So on average, firms produce more, and it's more wider, which means that firms produce more or less equally. Thus. And the analysis of these distributions, actual distribution and the effective one, allowed me to conclude that most of the Ukrainian manufacturing enterprises underperformed the optimal level of production, and most of them underperformed by more than 2 times. The less enterprise, the more the level of underperformance is. And speaking in terms of numbers, almost 87% of firms underperforms the efficient level of production. If we look through this efficient versus actual distributions of production, we can see that here are the quartiles by value added, and here are the quartiles by employment. First two columns shows those firms which underperforms, and third and fourth columns show those firms which overperform the effective level of production. So looking through these tables allowed me to conclude that small firms, almost all of small firms underperform their efficient level of production, whereas for big enterprises the situation is better, as some of them could even underperform their effective level of production. So the highest burden of these distortions is imposed on small and medium enterprises. I also tried to decompose this TFPR variance, so the measure of resource misallocation. So at first I decomposed it by output distortion and capital distortion. And the results showed me that capital distortion has a positive and more or less stable influence on resource misallocation. Whereas output distortions, they mainly determine the dynamics of the level of distortion. So output distortions are more variable and they shift the situation, so they influence the situation the most. Then I decomposed TFPR variance by components. So at first I decomposed it by between and within group components. Between group components means reallocation between different quintiles of productivity, and within component reallocations of resources within firms of the same quintile of productivity. So, and this decomposition allowed me to conclude that the major reallocations occur within industry, between firms of different productivity level, and the major reallocations occurred between the least and the most production, which means that while allocation of resources improves, so resources from the least and the most productive, they move to the mean of distributions. Thus, these tails decrease. They between shorter. Also, I performed some robustness check. Used both. Here I used real data, I also used nominal data. Results didn't change significantly. Also, the initial panel was unbalanced. I performed the same analysis for a balanced panel, and results were, and these potential gains were lower as those firms which remains during the whole period of time, so they does not enter, they are the most productive. So for them, these gains are expected to be lower. So exit and enter of firms, they affect misallocation in industry. Also, as I was mentioned that we take elasticity of substitution between different value added equal to 3. Xai and Klenov performed these robustness checks by putting sigma in equal to 5, and that's unfortunately that's the property of the model, that results are increasing in sigma. So if we increase the sigma, results increase, but I decided to stick to this sigma which they took in their baseline case in order to make results more comparable. Finally, working on paper, I realized, so from very beginning, that fixed effects estimation could be not very good for estimation of production function elasticities, and working on this paper, on updating it, I used Levinson-Petrine technique. So just to recall, basic results was from 97 to 135. Levinson-Petrine generated approximately 10% higher gains, so from 107 to 153. So probably Levinson-Petrine is better, and in updated version I will use this technique. So as for now, I have this result. Also, I performed some additional calculations. so that's the final part. For exit enter, so I've got that those firms which are less productive, they are more exposed to exit for exit. Those firms which have higher TFPR, they also have higher probability of exit, which could signal that as TFPR includes these distortions, so probably those firms which face more distortions, they have higher probability of exit. And those who enters are characterized almost 14% more productive and has TFPR by 36% higher, which we can conclude that this means that while they enter the market, so they have no ability to impose lower price. So at first they have to impose higher price. And also those who exit, they are almost twice less productive than incumbents. Also, I looked at market concentration, so increase of Hirschman-Herfindahl index by 1 standard deviation leads to slight increase of variance of TFPR by 0.7%. So if monopoly power in industry increase, this could lead to more distortions in the industry. Also, finally, that's for exports and imports. So those industry where the share of exporters is higher, they face higher variance of TFPR. However, those where share of importers is higher, they face lower TFPR, so they are more efficient. And exporters and importers as firms, they are more productive and have less TFPR, which means that they have enough ability to impose lower prices at domestic market. So finally, conclusions. This paper makes investigation on the impact of resource misallocation on manufacturing productivity in Ukraine during 2002-2010. I've applied Xien-Klenov methodology, and I've obtained results that full liberalization is expected to bring from 97 to 135% of productivity gains, whereas the US distribution of distortions could generate us from 34 to 60% of productivity gains. Also, we found that more than 84% of firms underperform their efficient level of production, and most of them underperform it by more than 2 times. And finally, improvement of business climate. So if we rule out these distortions, they could be crucial for return to economic growth. And as we found that the smallest firms are the most underperformance, so probably SMEs could contribute much to this growth if we eliminate these distortions. Thank you.
Okay, we had a change of the moderator on the go. I'm going to moderate the session, so Vadym has comments.
Thank you, Volodymyr. Okay, good afternoon already. So I thank you, Mykola, for a nice presentation, and of course, conference organizer to bring me here and being able to talk to many of you and to see my friends and to make new friends and to learn a lot about the reforms in Ukraine, and not only as an academic from the data, but also from the practical perspective. And I'm going to discuss this very nice paper, and I'm very glad that I'm discussing the paper of the one of the members of Institute for Economic Research and Policy Consulting, where I worked in early 2000s. So I see that this institute grew a lot and well, has a very capable employees. So I wish all the best to the organization. So the goals of these papers are stated as to measure the potential gains from elimination of particular kind of distortions in manufacturing sector of Ukraine using sort of very reputable metric of these distortions introduced by Shane Klenow in QG 2009. But you should not undersell your work, right? So you also extend it in a variety of ways. In particular, you try to explain what's driving those distortions by using, for instance, this technique to decompose HK gains into some components, which we can say, well, where they are coming from, right? So some of these components are responsible for what's going on within the bin of productivity, within the quartile of productivity among the least productive companies, or among the most productive, but we can also look at the component explaining how this different group kind of compare to one each other, right? So kind of groups. And we can dig deeper into it and see how it comes about. And this helps to interpret this measure in terms of what drives these results. And even next, Mykola tries to relate those components and those gains to some measurable factors, right? And he names it to provide a policy toolkit for liberalization, for reform in manufacturing sector. This is most interesting and most relevant, I think, for the policymakers, for academics to see how we can advance the development of Ukraine. And well, I think this is very important and relevant study. And let me, great minds think alike, right? So Mykola put the doing business report ranking in terms of distance to frontier, in terms of ease of doing business in Ukraine. So I decided to visualize it even in color, right? So I put, and those, well, all of us know geography of this part of the world, right? So we know where Ukraine is, and it's here. So the darker color means, darker yellowish and orange color means bad. The bluer it gets, it's better, right? So blue means you're very close to the best performance ever in terms of this metric. The reddish means the worst performance compared to the best practices. So this is the end of your sample, 2010. So Ukraine was faring worse than all Eastern Europe except for Albania, I think, right? So, and then by this year ranks, all of countries in the region advanced already in the blue territory except for handful of Balkan states and Ukraine, right? So there is a lagging behind in this doing business performance. So Mykola asks what's going on, right? So, and basically he very carefully studies the misallocation of resources, how firms use and misuse maybe these resources, in particular labor and capital in their production process. And he extends the standard framework by adjusting the framework for Ukrainian parameters, the cost of capital, shares of production. He popularizes nice work of the Institute to put together this data set of Ukrainian enterprises, cleaning it, and well, but we saw that a lot of us, a lot of people in this program really know a lot, deep knowledge about the Ukrainian data, so this is very nice. And he offers a lot of stylized facts. He starts a lot of stylized facts about distribution of Ukrainian manufacturing. And it's well positioned in the literature, right? So it's almost all work is done on Latin America. There is much less in Europe. So my colleagues, Shebnem and Carolina, they have work in progress about Southern Europe using similar methodology. And well, most importantly and most interesting, these findings drive some policy implications. So let me elaborate what he finds, right? So if Ukraine moves to the US efficiency in terms of TFP, it might improve by up to 60%, right? But what is interesting also, there is this nuance U-shaped pattern over time where we see there are gains in efficiency over the early 2000s, but then there is a dip, right, going back almost to the level of 2004 in efficiency. Because, and Mykola explains that it must have been associated with the crisis, right? And then, so what is responsible? So he finds that output distortions as opposed to capital distortions seem to be mostly to blame for these inefficiencies, right? And the most action, the most reallocation of resources happening between groups of companies not within the group, right? So it's happening between groups of companies in the top 25 and bottom 25 productivity bins, productivity groups, right? So not what is happening within each of the bins in productivity mostly driving these results. So this is a lot of kind of bigger extension compared to Hay and Klenov, so you need to push it more, I would say, right? So let's discuss what can be improved to make this, as far as this your thesis, into a nice paper, right? And I should say, so I've been communicating with him, and he probably implemented many of these things, and maybe partially I misunderstood it. So let me tell. So I would say we should focus more on less technicality, more on practical advice, right? So it's understandable. Okay, so we academics are in this world, you know, in our ivory towers almost, right? So we operate in terms of, you know, terms like elasticity, right? So, or I don't know, parameters, you know, heteroskedasticity. But well, if we want to be impactful, we need to translate sometimes this jargon into, you know, practical advice. What should be done? So I think we need to guide. So what measurable factors constitute these output distortions or capital distortions? You provide a lot of evidence, but I think you should put these decompositions more to the appendix and put what is in the appendix back into the paper, I think. That's what's interesting. That is what's different in your research versus, you know. So I would say you need to put more prominent role to correlations of these distortions with some measurable stuff, right? So size, ownership, expert status, industry. So what you already do, but kind of, you know, as almost sidelining it, right? So in policies discussed in section 5, right, referring to very important work in transition in Ukraine should be measured, put into regressions, correlations, graphs, and into the paper, I think. So also, to me, as international economist, is interesting, so how did crisis 2008 affect enterprises? Was it external shock? Was it homegrown? Right, so how, you know, integration of Ukraine via trade links, via financial links propagate into this? So was it, as I said, external policy, trade channel, and, well, interpret those components more. So, also, we've been discussing at this conference who is the right benchmark. So whose experience should Ukraine emulate, right? So, and I've been hearing, and I agree, that maybe Poland is better benchmark. Maybe EU average is a better benchmark, right? So of course, you need to replicate the result to validate them versus the US, but maybe you can take the input-output tables of Poland, which, you know, there is some input-output tables for lots of countries are available, and do it. Now, wage bill. So we can argue about this, right? So for instance, even Shay and Klenow, they adjust Chinese wage bill for non-wage payments, right? So there are ways to do it. In Ukraine, I think it's very important. There are a lot of informal sector, right? So I think, well, you probably need to adjust wage bill for informal payments. And there are ways, you know, we know some proxies of shadow economy. Estimating factor shares by this regression, it's sort of subject to Ackelberg-Caves Fraser critique. So you do Levinson-Petrin. This paper criticizes even Levinson-Petrin, offering Wooldridge extension of that. So it's about simultaneous determination for any inputs in productivity. So you show it matters, so you could improve even better. This is the most important. We need to sit and verify how do you calculate the table 9. So I suspect you interpret it other way around. So because HQ defined the columns under table 5 as the efficiency divided by actual size. So 0 to 50 means actual size is too large, so they should shrink. You say they should increase. Okay, so if you did it right, this means that your result is in odds with all the findings for India, China, and with the previous paper who show that there are more small enterprises, but they employ smaller number of workers at the time when efficiency improved. Okay, so but we'll see it, and maybe I'm mistaken. Okay, so now, so almost finished. So I'm also not sure what do you plot here on this graph. Is it if it's this or that? So it depends, but well. It's just for your reference, these slides, right? So different policy implications will result from what we know about the covariance of these distortions. Are they positive or negative? I'm not sure from reading the version I read. So on possible robustness checks very quickly, you can keep it. So it doesn't make sense to have the nominal data to me. Deflating capital stock by price of investment, this could be easy, as sort of usually people do, right? So this could be done, and then I'm also very interested. So what is going on for average firms within the? So are firms moving from distributions into the middle, or they always jump between extremes of distribution? So and what happens to market shares? So very careful implementation of original HQK paper for Ukraine with nice extension, lots of nice extensions. Extremely important for policy. More stylized facts and economics instead of technical stuff, please. Thank you.
Let's probably collect some more questions, and then we'll give a couple of minutes for Mykola to respond. Yes, please.
Yeah, Ola Havrilian. This is a superb paper, frankly, and if in the past 25 years that I've had experience in Ukraine, economic reforms and policy had moved as far as the study and research in economics that this paper reflects, we wouldn't have a problem today. Let me make 2 points and sort of in question form. Well, the first was just a comment. There is a huge amount of policy implication there, and it's very timely, because today, like in many developing countries on the verge of maybe moving forward, there is this common fear, almost universal, that we don't have any comparative advantage in the world, which of course is logical nonsense. This paper goes a long way to say that there's a huge productivity potential to make Ukraine a big exporter. On the substance of it, I wonder whether I missed something, or whether there is another element that you have missed. You worry a little bit that you are overestimating the gains because not all distortions will be removed. Sure. But you may also be underestimating them, because I'm not sure I see anything in your methodology and your model that really captures X efficiency gains. Certainly the literature of the past 50 years on ex post estimates of how much liberalization gave. First of all, it has always been on partial liberalization. Almost nobody had full liberalization. Often shows that the actual gains are far greater than early estimates would have indicated. So I think you needn't worry as much about that, and you can at least comment. Maybe you've got it there, maybe it's wrong. I think this is best summarized by something that a well-known personage in international trade theory once said, Max Gordon, when he was in Poland together with me on a World Bank mission, in explaining to the Minister of Industry, who said, well, we have no comparative advantage. How can you tell us that things are going to improve liberalization? Well, Max Gordon said, you know what? Be prepared for pleasant surprises.
Thank you very much. Do we have, you can keep it. Do we have anybody else who might ask some questions? Yes, no? Because I have several as well. Frankly speaking, I have been working with this kind of data since 2003, and some of my students and some of other students at the program also have been working with this data. And Mykola probably the first one who continues working with the data after graduation, so I cannot express you how glad I am that there is somebody else in Ukraine who also works with the firm level data at this very, very high level, because academically this is extremely highly, very high paper. I had a couple of questions over here. First, some technicalities. I couldn't understand how you treated outliers. It looks to me that you started estimating that your production function actually before you treated outliers. So it looks like if you, since in Ukraine we have almost Pareto distribution of employment, of output, and of most variables, those outliers can affect both the distributions and both estimates of the distributions, estimates of the particular coefficient. So I thought you might consider treating the outliers and kicking out of them out of the regression before you actually start estimating TFP, because something like 1% of the firms seem completely different from everything else, or maybe 2%. But you might look at this as well. Another thing. You were talking about coke and petroleum industry as one of the most distorted, and I think this is note both to you and to myself as well. This industry has one of the smallest number of the firms, and that industry is one of the most diverse in terms of the average size of the firm and the dispersion of the size of the firm. So probably this could drive your results, because if you're looking at the food industry has something like 5,000 firms per year, and this coke and petroleum has less than 100 firms per year. So this could be the reason why those results look so much different. So once you interpret the results, probably the size of the market should be treated somehow. And at the same argument goes to, for example, the monopolistic power of some particular industries and concentration of some particular industries, because in some of the industries concentration is huge, and this huge concentration basically means that you have some company with a huge monopoly power which looks like it has huge efficiency gain, whereas all others lag very far behind. But this is not because they are not efficient, but this is because they do not have this market share. And I think this is, once we are talking about efficiency should be somehow treated separately from the market shares. So this was my kind of most, those two questions that I wanted to show. Do you have any other questions? Yeah, sure.
Practical suggestion. I agree with Vadym that there's a lot of policy content, and you should market this. But I wonder whether a better way of doing it is to write two papers. Any paper that you write for policymakers that has even an appendix with equations may quickly get put on the shelf anyway. So just do a policy paper, for heaven's sakes.
Okay, do you have any couple of minutes to respond? We have just 3 minutes. Once you have a mic.
So thank you very much. Thank you very much for listening, for commenting, for asking questions. So at first I would like to comment presentation by Vadym. So I agree to both his pros of my papers and with all of cons of my papers. As with MAP, it seems that we are thinking in one way. So to tell the truth, I have the same ideas on how to improve this paper. So here I have no. I have nothing to add. I have nothing to add, so I agree with everything. So speaking about the comments on other different on other sources of these gains, so I used just the basic setup of Xi and Klenov model. So I decided to use this the baseline model to perform this exercise. However, there is a flow of literature where some other distortions are included, some policy implications are included. So I'm aware of this literature, but this paper I decided to start from this basic model. As here I used two-factor model. There are already extensions with three-factor model. It's still work in paper, but it was made by Bank of Portugal. So I presented their results here also. So that's is under my research. So I'm doing it. So I'm extending this methodology and answering Volodymyr's concerns. So yes, you're right. So I evaluated these alphas at first, as it was suggested by Xi and Klenov that we should estimate alphas, calculate productivities, calculate wages, and then based on these productivities and wages, trim outliers. So we trim outliers not by size, not by inputs, but by productivity and wages. And to tell the truth, afterwards I didn't recalculate it alpha, so probably I should do it once more. Second iteration. So I also agree with your concerns. And as time is out, that's all.
Okay, thank you very much. I declare the session closed. Thank you.